I can interpret the parameters of a linear function in context. Here's what you need to know. A parameter is a value that is held constant for a particular situation. So, for example, your slope and your y-intercept are called parameters. A linear function is a function whose highest power or exponent is 1. That means you don't even see an exponent. The graph of a linear function is a straight line with a constant slope, we call it m, and a y-intercept at some point 0, b. b is whichever value is up on your y-axis. Here's what the equation looks like for your linear function. Y equals mx plus b, but remember that when we're talking about functions, we use function notation. That means we're using f of x instead of writing y. It's the same thing. The f of x is your output. That might be your total, maybe the total cost, the total value, the total time spent on something. And your output changes as your input changes. Your slope is your rate. So that might be indicated by using the words per or each in a word problem. And it's also the common difference of the outputs. How are we changing every single time we change our input? Your input variable is what drives the entire thing. It's what changes value. You can plug in different values for your input. This is the only thing that can change. Usually your input variable is defined for you. It'll say, hey, your input is the number of boxes or the number of cars or something like that. It's usually defined for you. And then the number hanging on the end right here, the y-intercept, is a constant value, something that does not change. It might represent your initial amount, maybe the initial amount of money, something like that. It might be a flat fee that you're paying for something. It's something that does not change value over time. It also does not depend on your input variable at all. Again, it does not change value. Here's an example. The function a of s equals negative 4 times s plus 64 represents the amount of Oreos left in the package after s servings. What does the negative 4 represent in this situation? This is a linear function because the highest power is 1. I don't have any exponents higher than 1. Since we know it's a linear function, we know that the number that's being multiplied with the input, so the negative 4 times s, negative 4 is the slope. That means that every single time the number of servings changes or increases by 1, the number of cookies in the package decreases by 4 because our slope is negative 4. We're decreasing by 4 every single time s, or the number of servings, changes. So negative 4 represents 4 cookies being taken from the package for each serving. So we know that in this situation, our serving size is 4 cookies. S stands for the number of servings. Now you pause and try this one. What does the 64 represent in this situation? We already broke down that the negative 4 represents the serving size of 4 cookies. We were told that S is the number of servings. So the only thing we have left to figure out is what on earth that 64 is representing. Since this is a linear function, we know that it has a slope and it also has a y-intercept. 64 is in the place of the y-intercept. So let's think about what that means. A y-intercept occurs where our input is 0. So when s is 0, or the number of servings is 0, I have 64 cookies in the package. That means when 0 servings have been taken out, the number of cookies in the package is 64. 64 represents the number of cookies that come in a full package of Oreos. It's our starting value. Here's your next learning target. I can interpret the parameters of an exponential function in context. So we just did linear. Now let's take a look at exponential. Here's what you need to know. Parameters, again, are those values that are just held constant. For an exponential function, your parameters are going to be the rate and the y-intercept. We don't really call it slope, we call it rate. Remember how we did average rate of change? And exponential functions are a function where the highest power is the actual input variable itself. Your graph is a curve with a rate of change and a y-intercept of 0b. Here's what that function looks like. We have a of t, which represents your output. It changes as your input changes. We have your rate of change, which is like your slope, but we don't call it that. We call it rate of change. It's often given to you as a percentage. You have your y-intercept, or your initial amount, your starting amount. That's going to be a constant value that does not depend on your input at all. And then you're going to have your input variable t, which is changing value. Generally, your exponential functions are functions of time, but you may see an example where it's not time. Maybe it's the cost of something or the value of something, but a lot of times the t will stand for time. The entire expression right here in parentheses, just a reminder, the 1 plus or minus r, is called your growth or decay factor, and the way that you find that is by taking a common ratio of the outputs. So you divide your outputs. You take one output, divide by the output that comes before it to figure out how your expression right there is changing. Here's an example. The function a of t equals 200 times 0.87 to the t power represents the temperature in degrees Fahrenheit of a cup of coffee t minutes after it's poured. What does the 200 represent in this situation? So let's break it down. We know that this is an exponential function because we have a highest power that is an input variable. It's not a highest power of 1, it's a highest power of some variable. And we also know that t is representing for time, or the number of minutes that have passed by. 200 is in the place of our y-intercept. That means that if I put a 0 in for the t, 0 minutes after the coffee is poured, the temperature of the coffee is 200 degrees. So again, the way that we get the 200 is if I put a 0 in the place of t, this entire part right here where I'm hovering is equal to 1, and 200 times 1 is just 200. So plugging in a 0 for t gives me 200 as my answer. That means 0 minutes pass by, my temperature is 200 degrees. So 200, therefore, represents the initial or the starting temperature of the coffee before it has cooled down at all. So it's 200 degrees after it's poured. Pause and try this one. What does the 0.87 represent in this situation? So we know it is exponential function because our highest power is t. We also know that exponential functions have growth or decay rates, and that's the entire thing inside the parentheses. Since this is less than 1, I know that this function represents decay. That means my temperature is decreasing over time. It's decay also because you could write it like this. 1 minus the 0.13, which would be your rate of change, or 13%. That's what would give us the 0.87 that we see in the parentheses. But remember that your growth and decay functions always start with 1 for 100%, and then you add or subtract a certain rate from that. That's how we're ending up with the 0.87. We can work backwards to figure out that this would be a 13%, even though that was not given to us. So 0.13 or 13% would be the rate of change, and since it's a subtraction sign, I know that we are going down by 13%. So 0.87 or 87% of the coffee's temperature remains after each minute passes. So as each minute goes on, I'm only keeping 87% of my old temperature. I'm losing some heat off of this cup of coffee. So 0.87 represents a 13% drop in temperature each minute. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.